Chieftain Metals is pleased to present its plans to resolve the long-term environmental legacy of acid water drainage at the Tulsequah Chief mine site. The Tulsequah Chief project is located on the Teku River Tlingit First Nations territory in northwestern British Columbia, approximately 100 kilometers south of the town of Atlin, British Columbia. The solution will be divided into 3 phases. The Chieftain Metals project team has begun construction of an interim water treatment plant. Chieftain's Chief Operating Officer, Keith Boyle, explains.
It's a plant that we're building to deal with legacy environmental issues that have plagued that area for more than 50 years now. There were operating mines in the 50s that were improperly shut down, and water is running from the mine, the old mine, and it's acidic and it's running into the river. And so we're building a water treatment plant that will treat that acidic water and turn it into very clean water that'll be released into the river.
The water treatment plant is a short-term solution to treat the acidic water while the construction of the new mine takes place. Here's how it works. Acidic mine water is directed to a main settlement pond, which feeds into the interim water treatment plant. The acidic mine water is neutralized by the addition of lime, producing a slurry with metal hydroxides as the precipitate. Next, ferric chloride is added to aid in precipitation. Flocculant is then added to promote flocculation. The slurry is passed through a thickener, producing a sludge which is about 10 to 30% solid and stored on site. It will be included in the paste which will be used to fill the voids of past and future mining. The filtrate is then passed through a high-pressure filter to remove fine suspended solids. The clean water is then tested for turbidity, pH, and contained metals. If it passes the test, it is discharged into the Tulsequah River. If not, it is discharged back into the site settlement pond and treated again. Keith Boyle explains the second phase and long-term solution for acid water production.
The permanent solution to this environmental legacy is really to fill the voids that were mined in the 50s with some kind of fill material that will prevent the water from contacting the old ore and turn acidic. And so we're going to develop the mine that we're proposing, and with the waste that we're going to mine from this operation, we're going to fill those old stopes and stop the water from turning acidic.
The tailings and waste rock produced during the mine life will be backfilled into the old stopes from the 1950s and new stopes from below 5200 level. This will eliminate an oxygen-rich environment, thus oxidation of the exposed ore will not occur, preventing the production of acidic water. After year 9, the last year of mining operations, the plan will be dedicated to shutting down the mining complex. The water treatment plant and mill will be removed from the site, and trees and bushes planted in its place. The restoration of the site will be monitored by consultants and groups of researchers who will help us attain the best possible results. The replanted trees and bushes will be indigenous species adapted to the local climate. The goal is to restore the site by blending and contouring it to the surrounding land.
The mine is there, it's a springboard to do something really good, but leave something really good after the mine is shut down.